resume recording. So just jump three or four times, you can access this video. I strongly encourage you guys to watch this video and follow along, or just spend maybe 30 minutes before you go to bed and watch it. So that'll take you about 2 weeks. Then you have a pretty good idea and understanding of how to use this software. All right, next question is how's the recording link? Have you guys tried it? Nobody has like issues, right? Okay, sounds great. So I'll just keep doing that. And something really important I want to say before we begin our lecture is starting next week, because my job, I have a full-time job during daytime. I'm like transferring to a different site, so my commute time gonna be a little bit longer, and I'm not sure how long they're gonna keep, but I already told Tuesday's class, let's start from 6:30, somewhere between 6:30 to 7. So you can stop showing up at 6 and let's change it to 6:30. I may show up even later than 6:30, like 6:30 between 7, but just wait me here, okay? You can start doing practice so that by the time I came, you can start asking questions. But just don't think the class is canceled, and I will send out the official announcement on Canvas this weekend once everything is confirmed tomorrow. Are there any questions about this? And I'll make sure that every class finish before it's supposed to be finished. So, every lecture ends before 8:50. So pretty much we're just starting a little bit late and then, still do the same stuff. So I'm assuming everybody's good. I only got one person's feedback. Thank you, Trevor. Okay, so next week, we're gonna do that, and the following, in future, let's just keep doing that until I said different otherwise. So next week gonna be important because I'm gonna be introducing the first project. I'll bring out the project requirements, and I'll do an example of the first project, what my expectation is, and what is like the minimum requirements are. So please try to show up, because in that case, you can start asking questions. I can, if not, then, I hope you have a pretty good comprehensive understanding from the recording afterwards, but I still encourage you guys to show up next week, because first project is 50% of your grade and due at week 10, and next week is week 5, right? So I gave you almost 5 weeks to do it. I hope that's more than enough time, and definitely you should show me something, to prove you in this class for almost 2 months. All right. I just see the number jumps to 26. And there's somebody came in late and just missed the very two important part I just announced. The first one is regarding the class start time, and the second is about the first project. No, nobody? All right. Then we can start. So All right. This is assembly that I showed you guys last time. Uh, from week 1 to week 3, which is last week, we have been talking about parts, and we haven't. So pretty much we just talk about how to make a part, right? Very simple, straightforward, and that's why today I'm going to be introducing how to make assembly. At least make a simple assembly, not a very complicated top level assembly. So from here, you'll see how the parts are made it, and different relationship will give you different effect, such as for now, this is fully this is rigid, right? Yeah, this is rigid, but not fully rigid since it's a clamp. So it should be acting like it should be acting like a fixture that's clamping down on this pipe. So it's a little bit hard to see, but look at the edge of the pipe. If I move it, it rotates. So that's following the rule of physics, right? If you're not clamping down too hard, this totally can rotate within the groove and can be, wobbling a little bit. And also, if we get rid of one of the regulation or relationship, this this pipe can be even slipping. So sometimes when you build your model, it really depends how you set up the relationship, which right here we call it mates. So or constraints that will give you different, mobility or effect. And also these fasteners in the world, right now, like in this world, in reality, it can rotate, right? And they're totally able to be rotating. And since it's bolt on with since it bolts on with a nut, it cannot make any axial movement, which as we modeled. So that means this one you can play with once you've done modeling or constructing the assembly, you can totally play it and to see what the limitation is and what what's the remaining room of designing and such and such. Okay, any questions so far? If not, I'm gonna move to how to make this assembly. Okay. Then still, oh, by the way, just any, if you want check out any part, not check out, like if you want to see the detail of any part or component in this assembly, you can always hop over and just click, and there's an open part and there is open drawing. If there is a drawing associated with this part, you click this, you're gonna open up the 2D drawing and make it transparent, make it suppressed, and view maze and add a feature and all that. You get. I encourage you guys to try individual button to see what it does, and some button is super useful, and you're gonna use it over it again. So let's start making new part. I don't jump right into new assembly because this new assembly require parts, right? We need to make parts. All right, starting from scratch, we have nothing. And the first part I'm gonna make is the clamp. And before doing anything, I have set up two hotkeys, which I use in many times on this computer, which is the first one is the normal two, because this is almost a must-have during sketching. And the second one is under evaluate is measure. This is how you measure, get your dimension or distance from the other model to set up your current WIP part. So you can hover over, don't click anything, and right click, and there's a customize. Just customize right here in the keyboard. You search for the feature or the function you like. So first thing is measure. I set up to the number 1 on my keyboard, and the other is normal 2. I set it as n because n represents normal, right? So just FYI, you don't have to do this. To me, just save me maybe 2 seconds for clicking multiple times. All right, so pick a plane and let's make the clamp. So the first, if you don't know where to start or anything stop you, always good to make 2 center lines. Those are construction lines and will never hurt you, and you can get rid of them anytime. So once we have 2 construction lines and good coordinate system, a great question is for this time, because from last 2 weeks, every part I start building always start from origin. Is this part, the clamp, gonna be start from origin as well? Do you think that's gonna be a good idea?
No.
All
I think it would be a better idea to put the center of the part, or center of like the 2D projection of the part at the origin.
right. Well, yes, no, maybe. It really depends. Well, psychologically, if it is like totally yes, I wouldn't be asking, right? But it's okay. Depends on I want to bring out like the logic or your personal preference of modeling. So pretty much, let's take a look at the assembly right here. And let's separate out the clamp just by itself. So if we're making a flat sheet first and somehow bend it, I'm not sure how well that will go. So definitely start from this side will be harder or more difficult than starting from this side, right? Because pretty much right now, our tool is just revolve, extrude, and nothing else to add material, right? So once we have something, perfectly from the side, we can draw a profile and just extrude it to form the entire shape. Then that'll be easier to do. Then from this side, you start drawing something and extrude it, and you need to think of how to make up the top part. And also, the clamps works in pairs, right? So the 2 clamps are meant to hold this pipe. That means the inner diameter, which is the ID of one of the clamp, or either one of the clamp must be equal or greater than the OD, which is outside diameter of the pipe, right? Because if it's smaller, then your pipe will never be touching the inner of the clamp and is not fully engaged with all the surface areas. So that means your clamp is too small. You're pretty much not clamping on the tube or the pipe. So based on all those reasons, we know we better start from this view or this direction. And we have 2 clamps right here. That would be easier for us to start drawing the curvature by just draw the pipe out on your new sketch, right? because you can totally make this surface and that surface overlap. And this surface would just be an offset from this surface by whatever the thickness is. So that's why I'm saying sometimes depends on your own logic and your modeling preference. You may not start any modeling from the center. So let's figure it out what's the outside diameter of the tube is. And right here is 2.5. And let's do 2.5. All right, so right now I have the pipe. Let's assume there's a pipe, and this outside diameter is the outside diameter of the pipe, which I'm gonna set it as the inside diameter of the tube. So from here, let's just imagine, let me bring the rectangle tool, the center rectangle. We have one clamp right here, and we have another clamp right here. Well, I didn't make them perfectly identical, but just for you to visualize, and another semicircle or quarter circle on the top to give the thickness of the clamp, and also at the bottom. So now we have the entire model's profile, and we just need to get rid of something that we don't want and define the remaining things that we do want. Then we can extrude from there. Okay. So first thing, anything from bottom is what I don't want. And I need to somehow form the top feature, which has the thickness. And let's get the thickness, which is 0.25. And also set up the thickness from this side. And let's get the overall length. $7.5, and how far apart these two clamps should be as another quarter. So we can either calculate this number out, or we just measured it from this model since we have a reference model. And from here to here would be 0.25 divided by 2, since is the center line is not the surface of the other clamp. So for now, we do have the shape or the geometry of the profile of the clamp that we want to extrude with. And we have also a bunch of extra lines. So now trim entity and just start trimming. Okay. Okay, we have add the dimensions that we wanted to represent. All right, and let's go sketch the fillet. Since we don't want this sharp edge right here and this aggressive turn, want to make it smoother. And let's add the sketch fillet from here. And before that, we need to measure what the fillet is. So the fillet radius is 0.71. And the first one, 0.71. We can do all four all in once. So now we have the geometry of the profile and we can extrude it. And let's do overall width of 5 or length. And we have a identical clamp from the original assembly. And now we need to know what are the holes. So these holes are 1/2 inch holes and 3/4 from either side of the edge. So you can use any hole feature, and those were the simple hole and the hole wizard were used the most. And normally they will the difference is they will create a special feature that contains the host specifications. But for now, let's just use the extrude cut since it's 5 inches long. For now, let's just use the extrude cut to keep everything simple. And I'll have a different session about the holes and the hole wizard. So we can sketch, start on either there or here or from the bottom, up to you. So anywhere, draw a circle and set the circle to be 1/2 inch in diameter. And 2 3/4 from each edge. And after that, we can apply extrude cut. And from here, either through all or up to next, they both work. And click OK. We have the first hole made. And to form another 3 hole, you can repeat this totally 4 times, or you can use linear pattern. Either way, they're right. Just some is time consuming and gonna eat up a lot of your RAM. So under the linear pattern, there are 2 sections, direction 1, direction 2, and feature faces and all that. Those are those are fixed. Those are fixed settings. The only part you need to operate is direction 1, direction 2. So choose direction 1 as this edge, since this edge is in the x direction, and we want another hole to form the x direction, right? And the other direction we want it to form right here, so it's going to be z direction, which we will be choosing either this edge or that edge, any edge in the z direction as our direction reference. So done with two directions, we need to set up how many number of holes it's going to be we want in total. So we want 2 holes in this direction. The first hole is the original one, and the second one is the copy one. And same thing as this direction, right? 1, 2, 1, 2. So it's 2 and 2. So 2 times 2, that gave a total of 4 holes. And how far apart? The spacing. We know 3/4 from the edge, and the total overall length is 5. So the center distance from this hole to the new hole will be 5 minus 2 times 0.75. So going to be 3.5, right? So 5 minus 0.75 minus 0.75. And same theory for the second set. The only difference is the overall length is 7.5. 7.5 minus 0.75 minus 0.75. And it doesn't show up here. Where it goes? Let's zoom out. These 2 holes showed up right here, means we have opposite direction, and that's when this little arrow so we click that, they're going to reverse direction of the yeah, I'm going to reverse direction, and we have the previews on this side. So click OK. And here we have 1 clamp. And quick question for you guys. Do I need to make another clamp just like this? Anybody? Yeah, right. We don't need to make another one. We can just keep using this one and keep this the same part number. And let's save it now. So let's save it to I call it clamp 2 because it was called clamp 1 on Tuesday. So I saved it in a folder, and make sure all the parts which belongs to the same assembly saved in a same folder. That would be a good habit, because every single time when you open up SolidWorks from scratch and you try to load up a model or assembly, it tends to go the previous directory. And if not all the components in the same folder, it might have trouble to find it. It'll tell you like these parts are missing, and please navigate me to the location of those parts. And sometimes if you forget it, then if you forgot it, that would be a huge problem. So make sure save all your parts in one folder that for the same assembly. Even for different assembly, then it doesn't matter. So once we have 2 clamps, the next part is the bolting. All right. As I mentioned before, normally we never model or we never model fasteners, because either we get it from the SolidWorks design library, like down there, download the toolbox. So it'll give you NC, ASTM, like all different grade of the fasteners, or we just download it from supplier's website if it's customized. So don't worry about the fasteners. Today we're just gonna model it for fun to represent the to pretty much bolt on the two clamps. So it is not gonna be used even along your career. 0.74 from this hex cap screw is the distance from flat to flat. So normally the like those SAE specs will give you two values. One is from flat to flat, one is from hex to hex, and also give you the thickness of this. And the overall length will be a variable, depends on what suffix you choose or what part number you choose. And the thread length is also a variable, depends on which one you're buying. So in this case, this is totally made up. Don't count on that as a legit screw. You want to get the dimensions of any legit screws or something. You get a chart like this. So SAE grade A is what I use the most. That I believe that's the most widely used in commercial, because grade A has I think is it grade A is the highest yield strength and tensile strength, all that, and fairly cheap. So you will need a diagram and the measurements like this to construct the legit screw. But in this case, let's just let it go easy because it's just a demonstration. And the grade A is like this. You must see this somewhere, with all those leader lines on the top of the cap. All right. So let's get some basic measurement so we can just model this very easy. 1/4 length. And this is a cosmetic thread. And the length is 1 inch. So same deal, any plane, and there already a hex shape polygon waiting for you. Just click on that, and we have a hex shape, and just dimension it as 0.74 or 0.71. 0.74, right? All right, and let's extrude it. To a fairly random thickness. And now let's have the screw body. Since our hole is 0.5, I'm just use the same value for the screw body, even though we never shoot two, because in industry, the hole is always bigger than the screw. The nominal size of the screw nominal size normally is should be 1/8 or maybe 1/4 bigger. Depends on how tight you're on the positioning, how tight of the tolerance on your positioning of these of the holes are subject. So but this case I'm just lazy. Since everything happening in SolidWorks is perfect, in reality it's not. So let's just make it 1/2 inch and extrude that for 1.25. And here we have a fairly simple screw with 1.25 length. And now let's add some cosmetic thread. Even though this is not a legit thread, but it's helpful to have it so that we know where the threads are, and when we install it, are we using full engagement, and the thread length is long enough, such and such. But it doesn't really have any essential meaning. It's just a cosmetic, kind of like a layer on the screw body. So you just type in cosmetic thread, and the first one is right there. If it's dimmed out, like if you search something and it cannot be applied, it's dimmed out, then you must be either in another process, like maybe sketching, or in another feature setting, kind of like what I'm where I'm at right now, or the part cannot be applied with such setting. So first thing, thread setting. The thread setting is to select a circular model edge. And this is our edge right here. And starting a face or a plane, and which is the bottom. And standard, normally use ANSI or LS, depends on you. But in this case, let's get rid of it first, and I'll come back. So make it 0.49 since 0.5 is our screw diameter, the nominal size. It must be smaller, otherwise it's not going to be attached to the screw body. If you put it 0.51, it'll give you a warning saying it's not valid into between 0 or 0.5. So 0.49 is a pretty safe play. And since the thread is not going all the way to the top, we're gonna go blind and make it 1 inch. If it's going through along the screw body, you can go up to next or through. And it's not showing up, right? We can see a cosmetic thread is created right here. You can see the highlighted line, right? This orange line. So it's created, but it's not displaying right. It's because in the setting, sometimes SolidWorks will have the setting to omit some cosmetic setting. So that save your time when you open up the model. And also, it won't make your muscle look so messy. All right, so you search here, cosmetic, and even the first one, allow cosmetic thread for, no, not this one. So right here is document properties and detailing, cosmetic thread. And right here, you can see what's showing, what's not showing. If we click display all types, it'll show up. And also here has a bunch of different type of categorized stuff. And here is top level annotation. Pretty much, if you show this, it shows up everything within this model. But if you unclicked it, you're not able to see the cosmetic thread. So let's go back to the thread. So this is what manually set, right? And if we do go with the standard, it will ask you if it's machine thread or MPS and the thread size. So this is the real stuff that industry use. So sometimes if you have like a standardized screw and doesn't even have the actual thread on it, because if you use hundreds and thousands of those, that's 100 or thousands of extra feature to load up. So some model which is not even having it, unless it's NPT or something. Then they need something called thread countout on the machine drawing to indicate what kind of thread that's used, so machinists can know how to make it right. And here is what you're selecting. So apparently it's on number 5. That would be way too small. This is a 1/2" screw. So let's do 1/2 20 or 1/2 13. That's a different pitch. So you can see from here, the actual nominal size or diameter of the 1/2" 20 is only 0.44. It's far not 0.5. So once you add that, notice you don't have to choose your diameter again, and you will have this cutout. It is 1/2 20 machine threads. So on your machine drawing, when you bring up all the annotations, this will show up to say there is a thread for how long and with the spec. Because guess what? The cosmetic thread right here, it looks like this boat has threads, but in your machine drawing, it just looked like a hex cap and a cylinder. That's it. There's no actual shape of the thread, and of course, you're not able to see the cosmetic thread in your drawing. So we have our screw, and let's work on our bolt. Let's work on the nut. So the nut will be easy since just a hex cap with a hole and merely same dimension. So the same step as making the hex cap screw. And start making the through hole in the center. And again, we're gonna make this 0.5, even though it shouldn't be. And from here, we select through hole. This is gonna be a indeed through hole. And now we have a nut with less cosmetic thread. So same thing, thread setting. A little bit different this time is we're making a female cosmetic thread. On the screw is a male thread, and here is a female. So you need to select a inner edge instead of an external edge. And the starting plane or face is just either side. And we can select this. Yeah, the option of that one of the 1/2" 20 is gone since this hole is already 0.5. If we made this like 0.44, it's supposed to be there. So that's what so in this case we just manually do it. And diameter would be the opposite. For the male thread, it should be less than the diameter of the screw body. But for the female thread, it should be a little bit greater than the whole diameter. And also here, we don't do blind anymore. We do through, since it's gonna through out the entire internal length of the hex nut. And it's still not showing up. Either go with the option, search cosmetic threader here, turn on the setting, or okay. Okay. Any questions so far? You guys been really quiet today? Okay. So I'm assuming this is very easy stuff then. Everybody can just follow the recording and do one of the assembly themselves. All right, let's save it as hexdot. And save this one to be cap screw. And the last remaining part is the pipe. So before I made this pipe, normally all the pipe, no matter steel pipe or PVC, like in the industry, will follow NC pipe schedule. And this is a chart that I've been used in almost 2 different companies. And different schedule means different wall thickness. The value goes up, means the wall thickness get thicker. So schedule 80 will be thicker wall and stronger than schedule 40 in the same material. And the pipe size on the left column is the nominal size, and the OD in inches is not going to be changed. So the only thing changed in different schedule is the wall thickness and the ID. So the blueprint is in the thickness, and black print is in weight per foot, right? Yeah, per foot. So for example, the pipe I just made up has an OD of 2.5, and the ID I haven't measured it yet. The 2.5 doesn't fall into any category, so that must be a customized pipe, or that's what I made up. So if you want to clamp on a 2 inches pipe, because we just caught the nominal size just by how many inches. Like this is 2 inches pipe, this is 3 inches pipe, and what schedule is schedule 40 or schedule 80 or schedule 100. And for 2-inch pipe, schedule 40 or the standard, the same is wall thickness is 0.154, and the inner diameter will be 2.375 minus 2 times wall thickness. So if we are using a size 2 inches size schedule 40 in our assembly, then we're supposed to model the pipe per this value. But again, same theory as we just model the screw. This is just for a demonstration. So I can made up the pipe schedule, not pipe schedule, the pipe dimensions. And let's do this. So the inner diameter is 1.5 and outer diameter is 2.5, and overall length, I believe, was 10, 15. Okay. All right. Let's make sketch, and pretty much just to make 2 concentric circles. and make extrude. Okay, so right now I have a straight section of a pipe. If you want to make this curve, instead of extrude, just use sweep. Let's save it. Okay. So this is what we're talking about. We made 4 parts, and now we have 4 components, and the entire assembly can be constructed by these 4 components, right? And now we're ready to make the assembly. So create a new assembly, and it opens up kind of like a new part with nothing in there. You can either select parts from the left, and then, for example, I select this pipe 2, and when I hover it over, like it's right here, I just need to click one more time, it will be staying here. Or I can bring it out of my folder and just drag parts here. So either way is good. Or if I have multiple windows, I can even cancel the maximize, and wow, it's really laggy. I can even drag it from here. So so many ways, kind of like dragging file to upload is it will be up to you. Just make sure you find your most comfortable way to do it. So in this case, we need the pipe, and we have the pipe here, and we have the clamp, and we need another clamp, and we need 1 screw and 1 hex. But for now, I even want to remove the pipe. Just leave 2 clamps. I want to construct the 2 clamp first. I want to make these 2 clamps first, and then implement the pipe, and finally add on the fasteners. So still, again, this is my personal assembly reference, and you can totally do yours, which way is easier, but I just believe this is the most efficient way to do it. So under assembly tab, there will be, the first one is add a component, but I just really don't recommend you add any component within the assembly page or interface. You can see this is assembly, and when you go over to a part, it will tell you is a part file, not assembly file. So I really don't encourage you guys to make any parts change in assembly level until you have to, or until you are really experienced with it. Because sometimes like those features will crash your model and it won't read the model correctly. And especially if you swap any part with some modifications in the top level, that's not gonna be fun. Until you're really good at it, don't do it. So if you want to make any change to the clamp, click on it, open up, that navigates you to the parts file, and you make such change in here and save it, and Control Q, which is resolve it, and go back to the assembly. It will automatically reflect the change. Okay. All right, and then insert component, you're gonna bring the page. Once you at the very beginning, you can start dragging parts here. And the mate, which is the soul of the assembly, we're gonna use this over and over again. And component preview window, personally never used it. And the patterns and smart patterns and move components, all of this stuff you can pretty much find like either right click or so they're used in limited times. The OD of the pipe is 2.5, ID is 1.5. So we have two clamps and let's just mate them together to the way we want them to. So we know the two clamps are 1/4 inches apart from the flat surface to another flat surface. So let's do that first. Click on one of the surface and click on another surface. You can see they're automatically applied as coincident because SolidWorks is smart enough to think like to try to predict what you're trying to achieve. And this case apparently is wrong. We want distance because they're 0.25 apart. And right now they're 0.25 apart, but they look kind of weird, right? Right. So I want this clamp to rotate 180 degrees. So one concave up, one concave down. So here are mate alignment. You click on there, and it will, turns the opposite of the direction that you originally set it. And now they do fall into the direction I wanted, and I just need to keep adding more mates or constraints to make it like it's clamping on a pipe. So this time I'm gonna select this surface and that surface. And coincide or coincidence works good in this case. Now click OK. And this side and this side. And click OK. So let's get out of the mates and we can see our mates under individual component or individual part. This is a parts tree, different than in the parts file. That's your feature tree, right? So here the sub tree is your feature tree. So mates right here, and you need to click anything or just hover over. It'll tell you what are the reference surfaces that this mate involves with. And there's so many different ways to mate it to achieve this position. Like for example, we can like suppress that one first, and you can see like these two clamps are no longer constrained in this direction. So this time we can mate something else. Like we can mate the two through holes together as concentric. And it does the same thing. All right, so let's get rid of this. This is, like I said before, like the hole is supposed to be bigger and depends on what the tolerance of the positioning of this holes. It may not necessarily even be here. And, you use holes to reference sometimes is not the best idea. So, after that, let's bring in our pipe. And also there are multiple ways to do it since we just made the ID of the clamp the same as OD of the tube, OD of the pipe. We can totally concentric them. Okay, so you can see this pipe is slipping in between of two clamps, or normally the best practice of mating concentric subjects are creating axes. So now I'm gonna make a change. Pretty much in this pipe, I don't have any axes, right? I didn't create any, and there's no default. So I not Google, I search axis, or there's axis on my left right here. And they asked me to get a selection, and I want to make axis along the pipe direction. So I just choose any circular surface, and it's gonna bring me the axis, the axial axis, and I call it axis 1. And now we save it, put Control S, Control Q, and go back to our assembly. Model contain with assembly has changed. We like to rebuild the model assembly now. So pretty much it's asking, do you want to Control Q now? Yes. So from here, you see axis 1 is here. This is what I just construct. And once we have the axis, like there's nothing to mate with. And we're gonna go back to the clamp. And also make an axis of this circular area. And same, Control S, Control Q, go back to assembly. Now we have two axes. Even though it has this, once we made these two axes, it gave us the same goal of kind of like mating the outside, the outer surface of the pipe to the inner surface of the clamp. But actually, we are we are making this pipe like truly concentric to these two clamps. Maybe I described it in not very good way, but I hope you guys get what I'm saying. So normally when you have like a concentric part to another concentric part, well, I will try to make two parts concentric, just from axis to axis, plane to plane. That will be like the best practice, like very clean. And later on, when we make any changes of the clamp, the your overall assembly will not be affected. So you can mate this axis to that axis. And this time I'm not considering anymore, since those are just two three-dimensional lines and those are coincident, and click OK. And also here to here, we can use the distance. So this distance could be very arbitrary, depends on where which section of the pipe you want these two clamps to be clamped on. So you can play with the number, or you just simply don't put anything, just make it slipping the entire time. So in assembly level, things goes under defined is quite common because we need to keep adjusting our our assembly to accommodate the new design change, right? So sometimes we leave stuff floating, but we still we just constrain them in maybe one or two directions and leave 1 or 2 degree of freedom that work the best for us. So it's still like up to you.
I had a quick question.
Yes, go ahead.
So I understand that you told us to use the axial constraint instead of mating the surfaces together, but with the axial constraint, is there any way to make sure that the pipe doesn't move out of the clamp? Like I know in like for all reasons like that could just be we could just leave it within the clamp and leave it there, but I was just wondering because if you mated the surfaces, the part wouldn't be able to leave the clamp.
Mm, what do you mean by gonna be out of the clamp?
Like drag it outside of the clamp. Like if you move the pipe, you can pull it outside of the clamp on the axis. Is there any way to prevent that from happening?
Once you set up the two axes to coincident each other, like this pipe can only do axial movement, so
Right.
it would never be interference with the clamp body.
No, I get that, but
Uh-huh.
I meant I don't know if I'm saying this right. This is just more of like a trivial question, but like I was asking if there is a way to prevent the pipe from coming outside of the clamp.
Like slip out.
Yeah.
Oh, yeah, that's how that's why we set up this the second mate. But if you want like it still move freely and to prevent it not falling out of this the clamp area,
Mhm.
maybe, but I don't know at this moment.
Okay.
Yeah,
Thank
no problem. Yeah, because it's pretty much never concerned me. Normally, if we want to move this freely as slipping, and we like you already, well, let me think about it. Yeah, right. No, there is no such thing from my knowledge to set up like a boundary condition or something like that to like, oh, this is how you can only move 5 inches or only 10 inches. I never done that. Yeah, but probably there is a way. I can do some search and let you know next time.
thank you so much.
Yeah, no problem. That's a great question though. Okay. So once we have the pipe and we just need to install the fasteners. So the screw and the hex nut. We can drag multiple subjects at the same time. And this will be easy because the bolt just gonna be bottom out at this hole and going through that hole, and this gonna just be attaching on the screw body and also the bottom surface of the clamp. So first thing, let's do the screw body to the hole. And this time, we don't need to do any axial mating since it's fastener. So a lot of exceptions on fasteners because those are not that important. Well, they important to with respect to the bill of material, but in our modeling, since they are the least possible thing to be changed, they're not that important. So one example for you to realize that is like a lot of industries run FBA analysis on their machineries or whatever. And before doing that, guess what? If you have any interference from the pipe body to the clamp, that results in error. Because pretty much the FEA software like ANSYS or Nastran, like they won't understand like, okay, we have overlapped the material. And however, the fasteners, from every FEA will most likely be removed because they are technically now going to be counted into the structural integrity, and those ratings will just be applied how strong they're bounding together. So the modeling of the fastener sometimes can be a little bit loose, but when I deal with essential parts, you need to know the difference, like when you need to pay extra attention and when you can, save your time. So these two parts are made, and one more thing is on Tuesday, since I didn't grab the exact dimension from the screw was a little bit short. It falls into, excuse me. Excuse me. It falls under the nut. Thank you. So it will never be a good design. We always want to leave a little bit clearance or a little bit extra of the bolt. So same time, you need to ensure the full engagement of the thread length and with the nut. And also, you need to leave rule of thumb, maybe at 1/8 of extra extrude out of the nut. And the next is to apply the linear pattern. So same thing as we apply the linear pattern to make those holes. Components to pattern where we pre-select both, and direction 1 was still going to be the same. And direction 2 will also be the same. And sometimes you don't need to do the direction 1, direction 2. You can do reference feature and just reference a hole, and every hole have those, but that will be for later. Right now, just do both directions, all right? So 2 at each direction, and you can see the preview. One of the direction is wrong. And now we need to give the spacing, which is one is 3.5 and another one is 6. And from preview, it looks okay. And click OK. Then we have this assembly. Any questions? Okay, so this is a very simple assembly with only 4 components, which is less than 5. And in your project, I believe the requirement I gave you is 10 different components. So make sure you practice this assembly, the way to make the part, the way to make it, and till the very end, so you have a idea of how to make an assembly and ready and almost and getting ready for the project. So if you have no more questions, this is all I want to cover today, and think it should be pretty good practice for you. So you don't have any questions, you're totally free to leave. And if you do, stay here and ask me. And let me pause, stop recording.